Okay, so the first thing I want to do is first of all, you see it's a triangle. Easy enough, right? So what we're going to talk about today is we're going to talk about what's called a triangle mid-segment. We're not super creative, so it's a segment in the middle of the triangle, okay? And it's going to connect the two midpoints. Just based on this picture here, if I want you to find the midpoint of AC, can you see where that midpoint is? It's right there. So there's our midpoint. What would the coordinates of that midpoint be? 4, 4. Because what's in between 2 and 6? Remember, it's in between 2 and 6? 4 and 4. So that has the coordinates 4, 4. Okay, and then over here, the midpoint is here. So what's between 8 and 6? 7. What number is in between 2 and 6? 4. We already did that one. Okay, so here is the mid-segment. Okay? There are two things that are true about a mid-segment. The first thing is, if you just look at the mid-segment and its base, they kind of both go like so. What is true about them? They are parallel to each other. That's the first thing. How would I know for sure? Well, if I did the slopes, okay, if I did the slope of the first one, it'd be 0, because that's horizontal slope. If I did the slope of the second one, it'd be 0. So they have the same slope, so they're parallel. What's the second thing that's true? Here's the second thing. This is 1, 2, 3 boxes long. How long is the other one? 1, 2, 3, 4, 5, 6 boxes long. What's true about those numbers? 6 is double 3. Will that always happen? Yes. And I picked certain numbers so that it worked out nicely so you could see it, but it's going to work every time. There's really no way to prove this theorem except for in the coordinate plane with what we've done so far. So I kind of did it in the coordinate plane with numbers so you could see it. Those are the two things we're focusing on today. Those two things, parallel and it's double. Okay, so now back to your marks. Okay, so on your actual notes, the first thing we're going to do is we're going to write down what is a mid-segment. Okay, so the mid-segment of a triangle is a segment. You ready? So on the front side, first page. It is a segment connecting two midpoints. Okay, that's where the word mid-segment comes. Okay. Connects two midpoints. Now I connected 2 midpoints, but aren't there actually 3 midpoints within a triangle? There's the 2 that we did on the right and the left, but isn't there a midpoint on the bottom side as well? Yeah. So what we've got is we've actually got 3 midpoints. So how many mid-segments will there be? There's a mid-segment here. That's 1. That's the one that we just did. If we connect these 2, this is also a mid-segment. And this guy over here is also a mid-segment. So each triangle is going to have 3 mid-segments. Okay? So the theorem. So there's a definition of it, and then there's a theorem that goes through it pretty much for every single segment that we learn about in this chapter. There's a definition and a theorem. So what's the theorem? The theorem says a triangle mid-segment is parallel to its base and it's half the length. Okay, so I like to make things super colorful, so I'm going to switch over to some colors and I'm going to say right here it says a mid-segment is parallel to its base. Which one is the base to the mid-segment? Which ones go with which ones? So I'm going to highlight those out just so if you're a visual person so you can see that. So for example, MP, I'm going to lay the foundation, MP goes with the base AC. Okay? Question?
Will it always make it trapezoid?
The two together? Trapezoid looking?
Yeah.
Okay, so here's the other thing. I want you to notice the tick marks. Okay? M is a midpoint, right? That's what we were talking about. The mid-segment is the midpoint. So this has 1, 2, 3 tick marks. This has 1, 2, 3 tick marks. Let's pretend for a second, okay, that from A to C is a length of 10. Pretend that's a length of 10. So then, again, it's a midpoint. If it's a midpoint, what would be the length of A to N? Be 5, right? So if this is 5, then this would be 5. But wait a minute. This mid-segment is half the length of its base. So if this is 10, this one is also 5. Okay? Let me switch colors so that we can talk about the other ones that are corresponding to each other. So the mid-segment for MN, goes with the base of BC. Okay, so let's just talk about it one more time. Let's say the BC, let's go the other way. Let's say MN was 3. So if you know MN is 3, what's the length of BC? 6, be double, which means each part is 3 and 3. Okay? 3 here, a 3 here, and a whole length of 6. This should be pretty straightforward so far, yeah? Okay, the last two that go together are NP and AB. Let's say AB is 8. So then that would make these two both 4. It would make this guy over here 4 as well. Okay. So there's something that happens because of all of this that is not written down here at all. The question is, do you see it? And it's one of the reasons that using triangle mid-segments actually happens a lot in building and constructing houses and so on and so forth, which you're going to see here in just a minute. But what is true? What happened when I put all 3 of those mid-segments in that triangle? Okay, so yes, it is true that this length is 10 and this length is 5, but when I put all of those in there together, what happened and what is true about this little triangle here in the middle? That little triangle didn't really have anything to do with, our AC is double the length of MP, etc., etc. But do you notice that this little triangle in here is the exact same as the other 3 triangles? So the little triangle that was created by the mid-segments is the exact same as these other 3. Okay, let me prove it to you. You have here a side 3, a side 4, a side 5. Side 3, a 4, a 5. A 3, a 4, a 5. And then in the middle here, you have a 3, a 4, and a 5. So when you put those mid-segments on the triangle, fun fact, okay, it makes 4 exactly the same, which means congruent triangles. So there's also a little fun fact here. Creates 4 congruent triangles, okay, which you can use to your benefit when you're solving problems. It might help you to solve problems as you go. Okay, so that's all the information. Now let's just practice that information, okay? So I'm going to slide over to the right, okay? And on the right, it says we've got some given information, so I'm going to mark that information on the picture, and then I'm just going to answer these questions 1, 2, 3, and 4. Okay, so in the triangle, JR, I'm going to mark it with a tick mark, is congruent to RK, I'll mark that with a tick mark. KF, we give that double tick, is congruent to SL, double ticks. JT, down here, 1, 2, 3, is congruent to TL. Okay, so when you put those markings on the triangle, what they have told you is simply that, hey, these are mid-segments. That's what they've told you. This is mid-segments, and you can use this special rule. Okay? So the first question is asking you, what is RS parallel to? RS is the mid-segment that goes with which base? RS goes with, all together now, JL. When you say JL here on your paper, though, make sure you put a segment bar over top of it. We are still looking to, maintain that information from day one. Why? Because you have a final coming up. That's why. You still need to know those things. Segment bar goes over a segment. KL is parallel to, I heard it real quiet, like, put a segment bar over the top. Okay, here's where this piece of information comes in that you need to know that all four of those triangles are congruent to each other, because SL is congruent to what? Is congruent to what? So SL is congruent to KS. You already have that marked on there, right? So let's put a KS. And also, what else? RT. Okay, so again, KL, SL, and KS are on that line there. So that corresponds with this midsegment. So those pieces are all equal to each other. So this is R. Okay, last one. JR. JR is equal to its counterpoint right on that same line. RK, because they have tick marks, they have single ticks, they have single ticks. RK, because it's a midpoint, and then jump to that midsegment, because that midsegment is also going to be the exact same number, the exact same length, which is ST. Okay, so first part is just identifying what's equal to each other. Now we're going to use that information just with numbers. Okay, so this is an actual picture of some trusses that are used in building a house. Only one of the sides of the truss is the whole thing. That's what makes your pointed roof. Okay, so only one half of the truss is shown here. The other one's kind of light, but we're just working with this side over here. So it says that UV and VW are midsegments. So I'm just going to highlight them. So start with UV. So UV is this guy right here. Okay? So UV goes with which face? RT. I know that RT is 90. So what's UV? 45. So since they go together, you can find what that length should be. Okay, if you want it to be structurally sound, there you go. That needs to be 45. Okay, let's do the other one. VW. So VW, this time they gave us the little one. VW is 57. VW goes with which base? SR. How do I know that? Because a midsegment should be parallel to its base. When you draw those colors on there, they should look parallel, and they do.
Will they always tell you in the question?
They will either tell you or show you, because there's two. So here they told us that they were midsegments, right? Here they showed us that they were midsegments. So in some form, yes. Okay? So here, 57 times 2, 114 for this whole thing there. Okay, I didn't actually read the rest of the question. What did they want to know? It says find UV and RS. Just going back to remembering that you have to know the information from day one as well. Finding UV doesn't say, right there. It's right there. It's this right here. No, I get that. What they're asking for here is they're asking for the length. So I actually want to know the number length of that segment. So you write UV equals 45, and you do not put a bar over the top. It's been a long time since we've said that out loud, since we've talked about that, but that's a thing from Unit 1. You don't put a bar over top if you're talking about the number that corresponds with that picture. Okay, same thing for RS. So RS would be equal to 114. Yeah. Okay, pretty straightforward so far. We're just times them by 2 and dividing by 2. Okay, let's do it in a little picture. Find the value of x. Okay, so we're timesing by 2, we're dividing by 2. That means for answer 1, this is either going to be 4 or 16? Whoa. Hold your horses. Okay, I know that we're timesing by 2 and we're dividing by 2, but that only goes for the mid-segment. Is X the mid-segment length? No, but we do know that E is a midpoint. It tells us right here that DE is a mid-segment, which means this is a midpoint, which means X is just 8. Okay, so don't get 2 times by 2, divide by 2 happy. Okay, this one right here, 34, is the base, so half of that is X. So if I take 34 and I divide that by 2, I get X equals 17. Okay, there goes our divide by 2 times by 2 business. Okay, now that's boring. That's elementary. We got this. We got something a little bit harder. Okay, let's kick it up a notch. Right here. And this is going to happen on the test. Somebody is going to write, especially if they're on their phone at this time, somebody is going to write 2x plus 3 equals 50. Somebody's going to write down, does 2x plus 3 equal 50? Are these two, this little guy here and this one right here, are those the same size? No, so don't set them equal. But you can take 2x plus 3 and set it equal to 25, which is half. So you have two options here. You can take this one, 2x plus 3, and set it equal to half of the base, which is 25. Okay, so we take half of the base. We don't actually need to solve that. The answer is 11. Good for us. Good job, guys. Okay, but what is my other option? Because you're not going to want to do that divide by 2 if that's not a number. Okay, so your other option is that you can take the shorter piece and times it by 2 and set it equal to the 50, which doesn't make a lot of sense for this problem, but it is going to make some sense for the next one. Okay, so on the next one, you have 2 expressions. You don't have a number. Okay, the number is easy to divide by 2 or times by 2. When you have an expression dividing by 2, I can just take that off the table. Okay, we're going to times by 2 using the smaller one. Okay, if you're using 2 expressions, this guy is 4x plus 5. That's the smaller one. And then GJ is 3x plus 25. Now, that's deceptive a little bit because we have a 3x here and we've got 4x there. Oh no, 4x has to be bigger than 3x. No, it doesn't. Okay, so just we take the smaller one from the picture, take the smaller one, and you have to multiply that thing times 2 before you can set it equal to the big one. Okay, now this is what we need to have on our notes. Your notes does not have to have the answer. The answer is not going to help you on your homework. This is going to help you because it tells you what to do. Take 2 times that 4x plus 5 and then set it equal to the bottom part. This tells you what to do. You know how to do it from there. So what should I do that's going to help you more? The other thing I want to make sure is you distribute the 2 to both numbers, not just the first number. So when you double something that happens to be an expression, you got to double everything. Okay? Okay, that's it. That's all we got. So the other thing I want to point out to you is there's more papers on this packet, right? This is Monday's notes, Tuesday's notes, and Wednesday's notes, all in one packet. Okay? Which is also, if you're gone, and we're not going to talk about that, if you're going to be gone, you have the notes packet, you'll have the video, and you'll have the homework